Hey everyone! In this video we are going to be looking at solving questions about normally distributed data. Well, the first thing I'm going to start with is how we're going to cut up this normal curve into all the little pieces so that we can solve these questions. So if you've been working with normal curves, you should know that this big line right in the middle is your mean, the mean of your sample data. And then each of these lines to the right is plus 1 standard deviation, plus 2 standard deviations, and plus 3. And the same thing backwards, minus 1, minus 2, and minus 3. And even in class, if you've been studying this, you should know that these have very special values, where from minus 1 to 1, it actually contains 68% of the data, and from minus 2 to 2, it contains 95% of the data, and from minus 3 all the way up to positive 3, it contains 99.7% of the data. But what I'm going to be looking at here today is how we can actually cut this up and fill in each of these little parts. So what we're going to realize is that from this mean line, everything to the right is half, and everything to the left is half. So if I wanted to solve this little section right here and figure out what percentage of our data was in just this slice right here, because we know it's half and half, you can actually take that 68% and you can divide it by 2, and you're going to get 34%. And what this means is that because we know 68% is this whole region, we know that 34 of it is there, and 34 of it is there. We're going to look at the next little slice, and this is going to become helpful as we're solving these questions. So if I'm looking at this little sliced region right here, and this sliced region right over here, we know that from plus 2 to minus 2 is 95%. We know that from plus 1 to minus 1 is 68. So if I want to find how much is in these little regions here, we actually take 95 and subtract 68. When we do this, it equals 27. That means 27% of the data is in these two little regions on the side. And if I want to know how much is in each one, we do 27 divided by 2, and that equals 13.5. That means 13.5 of our percent of our data is here, and 13.5 is there. If you wanted to, you can go ahead and add these up. 13.5 plus 34 plus 34 plus 13.5 has to equal the 95. And just like that, that's how we're going to get this 99.7%. Because if I want to find these new little regions out here, we just have to take the 99.7 and subtract the 95. It's going to equal 4.7. Once again, same little trick. We can take that 4.7, which is shared between these two little segments, divide it by 2, and it's going to equal 2.35. That's 2.35 in each of these ones, 2.35 here, and 2.35 there. If you really want these little tipsy tails, so beyond 3 standard deviations up and beyond 3 standard deviations down, all you need to do is realize that that's 100% of the data. So 100 subtract 99.7 equals 0.3, and this last little bit is 0.3 divided by 2, which equals 0.15. Itty bitty teeny little percent, 0.15% there, and 0.15% there. But what we're going to do now is apply this to a little real-world example, and you can see how these numbers help. So let's go ahead and look at some normally distributed data. We weighed 240 cats and found the data to be normally distributed. Now, that means it went according to one of these normal curves. They had a mean weight of 6 pounds and a standard deviation of 0.8. And the first thing that we want to do is make this normal curve. So we can go ahead and label these. Our mean, which is 6, goes right in the middle here. As we go up, we need to go up by the standard deviation, which is 0.8. So our next little point here will be 6.8. We add 0.8 again, and we get to 7.6. And we add 0.8 again, and we get up to 8.4. We're going to do the exact same thing the other way, subtracting standard deviations. So we subtract 0.8 from 6 to get 5.2. We subtract 0.8 again to get 4.4. And our last little point down here is 3.6. So now we have our normal curve all filled out. Let's go ahead and do some calculations. Out of these 240 cats, how many cats would you expect to be 6 pounds or more? Because 6 is right in the middle, and 6 pounds or more is this whole right-hand side of the normal curve, we can actually say that that is 50%. But because we've been given an actual number of cats, 240 cats, this question actually wants a number. It doesn't just want 50%, it wants a number of cats. So to do that, we take 240 and we're going to multiply by 0.5. That's because anytime you multiply by a percentage, you got to divide it by 100. What this is going to equal is 120 cats. Out of our 240 cats, we would expect 120 of them to be 6 pounds or more. Part B says, how many cats would be between 5.2 and 6.8 pounds? Between 5.2 and 6.8 pounds, that's our 34 and our 34, that's our 68%. This is still a little nice one. You'll see a trickier one here in a moment. Because this is 68%, we want to turn this into an actual number. 240 multiplied by 0.68 is going to equal 163 cats. So out of our 240 cats, we would expect 163 of them to be between 5.2 and 6.8 pounds. Here's the first chance that we get to actually use the fact that we broke our normal curve up into little itsy bitsy pieces. How many cats would be between 6.8 and 7.6 pounds? Now, if all you used was the distributions that you were given, that's 68, 95, 99.7, this isn't actually one of those ranges, because 6.8 to 7.6 is right here. But because we took the time to chop our normal curve up, you can always use this. Once you know these numbers, they don't change. You can use them every time. We know that between 6.8 pounds and 7.6 pounds is going to be 13.5%. 13.5%, which we can turn into a number. 240 times, remember to divide it by 100, 0.135, which is going to equal about 32 cats. See how much that makes it easier once these are all cut into little slices? You can do any region you wanted. Last question. How many cats would be 5.2 pounds or heavier? Again, here's our 5.2. We want this entire region over here. You can save yourself a little bit of time here when you realize that from the mean up is 50%. So we know that it's at least 50%, but because it's also this 5.2 to 6, so it's 5.2 pounds or heavier. That's everything 6 and up. We've already solved that that's 50%, but it's also 5.2 and up, so it's this extra 34%, giving us a total of 84%. We want to turn that into a number. That is 240 multiplied by 0.84 is equal to about-ish 202 cats. So this method works on all sorts of normally distributed data, not just a whole bunch of little chunky fluff balls, but you could be doing this for any type of normal curves that you're working with. I promise you, if you cut your normal curve up into little bits and pieces first, and you know all of those little percentages, these questions are going to be a whole lot easier. Good luck solving your problems, and if you have any more questions, please feel free to leave them in the comments below.